Hello everyone, welcome back. Today we are going to solve a classic and the most fundamental stack-based LeetCode problem, valid parenthesis. The problem statement is very simple. We are given an input string containing just the characters opening parenthesis, closing parenthesis, opening curly brace, closing curly brace, opening square bracket and closing square bracket. And we need to determine if the string is valid or not. Now a string is considered valid if these three conditions are met. First is open brackets must be closed by the same type of brackets. Say we have a string with these two characters. We can see that this open parenthesis is closed by the same type of parenthesis. So this is a valid string. But instead if we see a string, say which is opening with a square bracket but closing with a parenthesis. So in this case we can see that this is an invalid combination. The next rule is open brackets must be closed in the correct order. For example, first we have an opening parenthesis and then a square bracket, but while closing, first this square bracket is getting closed, then we have a closing parenthesis for this one. So this is a valid string. But for example, we have a string like this in which we can see that this is opening with a parenthesis and then we have a square bracket, but after this we are expecting a square bracket so that this get closed, but instead of that we are getting a closing parenthesis, which is not the correct combination. So this is an invalid string. And the third rule is every closing bracket should have an opening bracket of the same type. That is, suppose we have a string like this. In this we can clearly see that this opening square bracket is getting closed by this square bracket. But this closing parenthesis is alone and it does not have an opening parenthesis here. So this is an invalid string. But suppose we have an opening parenthesis here as well. In that case, it would have been a valid string. So now let's see how we can solve this. See, this is our input string, and if we have to solve this problem in a brute force way, what we will do? We will keep scanning each element in the string one by one and check if it is an opening or a closing bracket. The first one is an opening bracket, next is also an opening bracket, third one is also an opening bracket. When we come to the fourth element, we can see that it is a closing bracket. So once we get to the point where we find a closing bracket, then we need to see if it forms a pair with the previous element. That is, if there is an opening bracket for this element or not. In this case, we can see that these two form a pair. So we know that we can eliminate this pair from current string. So our string in consideration will now reduce to only this part. And we have to repeat this process again. So this is an opening bracket, this is also an opening bracket, and the third one is also an opening bracket. But the fourth one is a closing bracket. And we can see going backward, thus we have a opening bracket for this bracket as well. So this also forms a valid pair and we can eliminate this from our current string. So now our string in consideration again reduces and it becomes something like this. So you can see that we need to continue this process again and again until no valid brackets pair is left or the string is empty. So finally either we will have an empty string or we will have some dangling element left. If the string is empty, that means it is valid. But if there is any dangling element left, then it is not a valid parenthesis string. Another point where it can go wrong is, suppose while scanning the list, if we reach an invalid pair, say instead of a correct pair, we have a wrong opening parenthesis for a current closing parenthesis. In that case also, it will be an invalid string and we can directly return. In this process, as at each step we are creating a new string, so we need at least O of an extra space for this process. Also, if we see the time complexity, in that case, we can see that at each step we need to scan the entire list, which itself takes O of n time. And in worst case, we may need to do this n by 2 times. As in each iteration, we are removing one matching pair which consists of two elements. So till the time we reach an empty string, we might have already scanned through n by 2 times, which makes the overall time complexity quadratic in nature, that is O of n square, which is not very efficient and we can do better than this. Notice that when we are scanning the list and reaching a closing bracket, in that case we are looking back to find a matching opening bracket at the most recent position and then removing it. And removal from the most recent position or the last position can be done very efficiently using a stack data structure in constant time, as stack follows a LIFO structure, which is last in first out. Say we have a pile of plates. So while placing the plates, you can see that the bottom plate is the first to be kept. and the top plate is the last to be kept. But while taking out, the top plate becomes the first one to be taken out, and eventually bottom plate becomes the last one to be taken out. This is what LIFO structure means. So this is called the top of the stack, and we can insert any new element at the top in O of one time, as well as we can pop the element at the top in O of one time. That's what makes the stacks efficient. Now let's solve our problem using stack, which is the efficient approach. Now say this is our input string and we have our stack here. When we start scanning our list and see that the element is an opening bracket, in that case we add it to our stack. This opening curly brace will be pushed to our stack. Next we will move to our next element and we again see that this is an opening bracket. So any opening brackets will be pushed to our stack. So we push this opening square bracket to our stack. Now we move to our third element and this is also an opening bracket. So we will push it again to our stack. The next element is our closing bracket, and this is where things become interesting. So when we have a closing bracket, what do we need to check? We need to see if we have already seen an opening bracket corresponding to this closing bracket or not, and that we can easily verify by looking at the top of our stack. And we can see that there is a opening bracket which matches this closing bracket. That means these two form a pair. So we can easily eliminate or pop the top of our stack. So now our stack only has two elements. Now we will move to the next element in our string. This is also an opening bracket, so we will push it to our stack. The next element is a closing bracket again, and now we will again go and look at the top of our stack, and we find a matching opening bracket for this closing bracket. So again we will pop the top of our stack. Now we move to the next element and we can see that this is also a closing bracket, and we can see that we have a matching opening bracket for this top of our stack. So we will pop it again. And the last element is also a closing curly brace, and when we look at the top of our stack we can see that there is an opening curly brace, so we can pop it again. Now we have reached the end of our string and there is no other element left, and also our stack is empty, so we can return true and we can say that this is a valid parenthesis string. But suppose there was something already left in the stack and we have reached the end of our string. In that case we can say that there is no matching closing bracket for this one, so we can return false. Also, if we had some closing bracket left here in the string and there was nothing in the stack to match, in that case also it would have been false. Note that whenever we reach a closing bracket, in that case we are looking onto the stack to match their opening counterpart. And this one-to-one mapping of opening to closing bracket can be very cleanly done using a hash map. But this is not necessary to use a hash map. You can do it with inline conditions as well. But I will say using a hash map definitely makes it a bit cleaner. And also, as there are only three types of brackets that we need to push into the hash map for lookup. So the hash map technically takes constant time to build and constant space and does not affect the overall time and space complexity. Now we can see that in string of length n, we are scanning through the string only once, and we are pushing every open parenthesis once and popping it once, which are both constant time operations. And in worst case, all the elements can be opening brackets. So overall the time complexity becomes O of n. Also, as we are storing all the opening brackets in the stack, and in worst case all the elements can be opening brackets, so the memory complexity will be O of n due to the space used by the stack. Now let's dive into the code. We'll create the dictionary where we will map each closing bracket to its opening counterpart. Now we will create our main data structure, that is the stack, which we can create in the same way as we create lists in Python. Next we will scan through each character in the string, and if that character is an opening bracket, which we can easily determine by checking if it is in the values of our hash map, in that case we will simply append it to our stack. So stack.append the character. Otherwise, if it is not an opening bracket, then it is definitely a closing bracket, because the question mentions that the input string will only contain the characters which are brackets. In that case, we will check if the stack is not empty and the top of the stack, which we can check using stack of -1, matches the opening counterpart of the current closing bracket. So if it matches, in that case we will pop the top element from the stack. Otherwise, if the stack is empty or the top of the stack does not match the opening parentheses, in that case we will directly return false. Finally, once the scanning is done, we will return true if the stack is not empty, otherwise we will return false. The same thing we can also write by returning if not stack. It will give the same answer. Now let's run this. We can see that this works fine and is pretty efficient. I hope this was helpful. Feel free to comment your queries if any, and do hit that like button and subscribe to DKodeTree. Thanks for watching. See you in the next video.